Hi friends, hi everybody. So today we'll be taking up a new problem with a plate with a hole problem. So this type of problems are particularly seen widely in aerospace industries, where we generally find a lot of cutouts near to the ribs, spars, in the skin panel. Also in the fuselage also we have got a lot of cutouts to make way for fuel entry for that avionics lines. We have a lot of cutouts in the ribs to make passage for that cable routing, for that looming, for weight reduction and all. So these particular areas of plate with a hole problems, when subjected to quite a high load, the area of discontinuity, that is the hole inside the plate, you can find that very high stress concentration is seen in the vicinity of a discontinuity in a plate. So we are very eager to capture such things, since the application is mostly in the mechanical, aerospace and automobile structure. So we will be solving today a very fundamental problem of a plain square plate and a hole in between that, and it will be subject to tensile load. Of course, if you are interested to find out the stress concentration, the whole plate must be subjected to tensile loading. So that is what we are going to do, and we are going to solve the entire problem in Patran 2014 version. So here we start. So first let us create a file name in desktop, wherever you feel comfortable to keep the Patran files. Just make a name for that. So inside the folder I'll take 1. So 1 is not existing, so it will create by its own. For our own comfort, I'll change the background to be black. So I'll create 4 points. First is say 0 0 0. The second one we can take as 100 0 0, then 100 100 0, and 0 100 0. Points are not visible, so I'll put that point symbol on. Now it is visible. Now I'll join the points with a curve, say from one point to another point. I'll make a circle in between, so create curve. So for that I'll first create a point. For that, create point. That inside point will be 50 50 0. Now I'll create a circle, that 2D circle. It is asking for a radius, say 10, and the center point I'll select this one. So it's quite small, I'll make it a bigger circle, let's say 20. Okay. So it's done. Now I'll just create curve from point to point. I'll just join from here to here, and I'll create another curve from here to here. I'll just make it into 4 quadrants. So what I'll do is just edit curve break. I'll break this curve out here. I wanted to break, but there is no point existing, so I'll make a point. Create point on the intersection of this one and this one, again this one and this one, again okay, those 4 points are there. So edit curve break. I'll break these curves out here, okay, this curves out here, okay, this curve out here, okay, this curve out here, okay. So the curves inside, I'll delete it. So whatever is coming inside the circle, I am not interested, so I am deleting. Now this circle also, edit curve break. I am breaking this circle over here, this circle over here, this circle over here, this one over here. See, these two separate circles have formed, so I'll just merge these two curves. So I got 4 quadrants, so I'll make 4 surface out of it. Create surface edge, 4 edges, this one, this one, this one, this one, sorry, this one, sorry, picking is wrong. So this one, this one, this one, and this one. So if it's not visible, just put that surface on. Again, I'll go for this one, this one, this one, and this one. Again for this one, this one, this one, and this one. See, it is not formed, so it is not properly picked. Let us pick it once again. This one, this one, this one, this one. Again this one, this one, this one, this one. So it is properly picked. It is not visible properly. Slight haziness is there. So I'll go for display light sources, put entire thing on, apply. So now it's fine. What I'll do now is just mesh these things. Before meshing, I'll take a material. So create point isotropic material, say is aluminum. I'll assign some properties to it. So that is done. Now I'll go for meshing. Create mesh surface. So this is my mesh. This surface I am going to mesh. See, it is meshing like this. So I'll go for little finer things, and the same thing I'll maintain for all the 4 surfaces. It looks quite good, but I am all keen on capturing what is really happening in the area very near to the vicinity of this point of discontinuity, you know. So I'll go for further refinement of mesh. Finer is the mesh, better is the result. Okay, this looks quite good, and similarly I'll mesh all of the surface. So it has taken an automatic this thing calculation, so I'll go for 4 as it was taken earlier. Now I'll go for equivalence. So it's done, and what I'm going to do now is application of forces and all. So let us fix the entire downside portion. So go for load and boundary condition, create displacement. I'll just constrain all the translations and all the rotations in the downside portion. Okay, pick the entire region, downside, add OK, apply. Now it is created. We have given the boundary conditions. Now loading remains. So I'll create distributed load. Say load, give a name out there, and it is in the y direction. So we'll assume in the y direction there is a load of 100 Newton distributed all along the free edge. Just connect the free edge, and I'm over here. I'm connecting all the elements that are free in the top. Add OK, apply. See, it has the way we have selected the 4 systems. It is looking down, so I'll just change it. So modify distributed load, this one. Modify data. What I'll do is I'll just change the sign. Apply. Now it's fine. And okay, what else We have applied the loadings, we have meshed it, we have taken materials, we have provided the boundary conditions. Now we have to take properties. So I'll just give the name and properties, material name, say whatever material we have taken, aluminum, thickness say 2 mm. Okay. Application region it is asking for, so since here there are no tri elements and all quads, I'll take quad element. I'll assign the property to all the quads what I have made. Okay, and apply. So see here it is written property set shell is created. So everything is almost done. Now we'll go for analysis. Analyze deck. Okay. Now just go to Patran. Sorry, Nastran. Nastran, it is asking for the PDF file, that is the input file for Nastran to run the analysis. I'm just identifying the path for the software. Run. We have to see for any fatal message, whatever it may appear. So just see what happens. The run is over. I'll just click the output file, that is the F06 file in Notepad, and see there are no fatal message. Just scroll it down, you can have all the data for all elements, all nodes. Okay, I'll just see the results. Now access result, select result file. XDB is the format it was chosen by default, and okay, apply. Now coming to result, I'll first see the stresses. Particularly we are interested in the von Mises stresses. The position is Z1, Z2, that is the upper and lower surface of the shell we have created. See, it is looking like this. So it is absolutely what is expected out of it. The stresses or the force system that is applied at the free edge and the stress that is being created out of that, the stress out here should be around 3 times. But it really depends on the stress concentration, so we have to follow the book of Peterson and find out the stress concentrations that would be appearing or that would be applicable in this case. So typical problems of plate with a hole will end up with a stress concentration Kt of the order of 2.6 to 3. So we should also get that. Now the stress flow, as you can see, is perpendicular to the direction of loading. It should be like that. See, the maximum load is out here and it is flowing rightward here and leftwards portion over here, but it is the stress flow is perpendicular to the applied loading. You can see all these lines because geometry is on, so what I will do is I will just put off the geometry. Now it is much clear, and if you put that this thing deformed shape on, so you can see that what way the things have really deformed. So this spider mesh which we have created with the quad elements, it is showing that earlier the shape was like this. Now being stretched, it has taken the shape of a ellipse. So if you can animate the structure, you can find the behavior. It should behave like this, and that is what is expected out of this. Now we will just refresh the skin and we'll see the displacement plot. It is like this. So here it is all held by 1, 2, 3, 4, 5, 6. That is the translation and the rotation things are held. So it shouldn't show any displacement, and that is what it's showing. Just see the top portions. Since it is pulled from the top, we are seeing a lot of red marks out there, and the inside dia hole which was a perfect circle has now become an ellipse. So whichever result you want to see, that you have to just go to that F06 file and look out for the result at that particular node, select the ID number and the corresponding displacement, stresses, all data can be seen in the F06. So that's it, friends. If you want a theoretical explanation of this thing and a theoretical correlation, please come back to us. Just contact us through our website www.dsnaerospace.com. You can request us a webinar. We are free to it, and we can arrange a webinar to any locations in the world. So in that particular webinar, we will definitely clarify all your doubts, and we can have theoretical explanations of our problems. We'll see that the theoretical thing and the Nastran results matches almost 100%. So that's it, friends. Thank you so much.